Okay, so this is a video on how to graph rational functions, find their domain, range, and most importantly, their vertical and horizontal asymptotes. Please take a moment and find this page in your packet. Okay, so the first thing we're going to do is we are going to use our graphing calculator to identify the vertical and horizontal asymptotes of these rational functions. You'll remember when we did logarithmic functions, they had a vertical asymptote, and the vertical asymptotes all took the form x equals. And when we looked at exponential functions, they all had horizontal asymptotes, and horizontal asymptotes all took the form y equals. Well, now we're going to start having functions with both horizontal and vertical asymptotes. So let's get started. The first thing you're going to want to do is go into y equals on your calculator and type in number 1. You want to make sure that you put the numerator in parentheses and the denominator in parentheses. So it's going to look like this. Y equals, clear out anything that's here, then we have x plus 1, close parentheses, divided by x minus 1. And then you're going to go and look at your graph. Now, depending on how old your calculator is, you may see some lines here, and that's normal depending on the operating system. What I notice is that I seem to have a vertical asymptote. My graph seems to be trending towards the vertical line, x equals 1. And horizontally, I seem to be trending towards the line, y equals 1. Now, if I'm not sure and I want to double check if I have access to my calculator, I can go and look at the table. And you'll see when x equals 1, I have an error. That's another way I can confirm I have a vertical asymptote. Now, for the horizontal asymptote, as you look as x goes to infinity and negative infinity, you should see that the y values are trending towards 1. And you can see here they are. What I would like you to do is, with a partner, graph the remaining 5 functions and find their vertical and horizontal asymptotes. Make sure you always put the numerator and denominator in parentheses so you don't have any problems with your calculator. I'll do one more with you. For number 2, I really don't need parentheses around the numerator, but I can put them there if I want, if it makes me feel better. I've got x cubed. I don't need parentheses again because it is a monomial and there's no coefficient, divided by x squared minus 9. When I look at the graph for this function, it's kind of funky looking. It doesn't appear to have any horizontal asymptotes, but there looks like there could be 2 vertical asymptotes here at -3 and +3. So if I want to, I can go and look at my table to confirm that. Oh, there's the error. So clearly there was something going on interesting at 3 and also at -3. So I have vertical asymptotes of x equals 3 and x equals -3, and I have no horizontal asymptotes. Take a minute and pause the video while you type the rest of the problems in. Okay, so if you type the rest of them in, you should have found that number 3 had a vertical asymptote at x equals 1, -1, sorry, and a horizontal asymptote of y equals 4. Number 4 had a vertical asymptote at x equals 0, and it had no horizontal asymptote. Number 5 had a vertical asymptote, actually at 2, at x equals 1 and -1. And do not write plus or minus. And it had a horizontal asymptote at y equals 0. And lastly, number 6 had a horizontal has a vertical asymptote at x equals -1, and another one at x equals 6. It had a horizontal asymptote at y equals 0. So what I want you to do, first we're going to take a look at where do these vertical asymptotes come from. Well, all of these are rational expressions, and so they're all division problems. We all know that the one thing you cannot divide by is 0. So if you think about it, anything that makes the denominator equal to 0 is going to turn into a vertical asymptote. Think about it. Here I've got 1. If I do 1 minus 1, that gives me 0. If I put in 3 or negative 3, that would give me 0. Here 0 makes number 4 0, negative 1 makes number 3 0. So that's where all my vertical asymptotes are coming from. The horizontal asymptotes are a little trickier. So what I want you to do is read number 7. It says, based on the problems above, complete the following. In a rational function, when the degree of the numerator is the same as the degree of the denominator, the horizontal asymptote is blank. So let's look for problems where that occurs. Where are the degrees the same? Well, let's see. Number 1, they're the same because they're both 1, x and x. Number 2 is no because that's 3 and 2. Ooh, number 3, x and x. And that's it. So let's look at number 1. Here we have y equals 1. And here we have y equals 4. Where do we see a 4? Right here. So if you think about it, 4 divided by 1 gives us this y equals 4. We get y equals 1 because it's 1x divided by 1x. So, for example, if we had a function that was y equals x squared divided by 3x squared plus 1, that would have a horizontal asymptote of y equals 1/2. So it would be like 1 divided by 2. I'm going to summarize this on the next page. I've left more room, but I just kind of want to go through this now, and then we'll type up the official rules. So the next one says, in a rational function, when the degree of the numerator is less than the degree of the denominator. So let's see, degree of the numerator has to be less, so smaller. So not 2, that one's bigger. Not 4, that one's bigger. Oh, here we go, 6 and 5. This is 1 and this is squared. This is 1 and this is squared. And they both have horizontal asymptotes of y equals 0. Okay. Now, the reason that is that if I take a small number and divide it by a large number, so if you imagine I put 1,000 in for x, 1,000 minus 2, well, who really cares about the minus 2 if you have 1,000? And again, no one really cares about these terms. Divided by 1,000 squared, it's going to be a really small number. It's never going to get to 0, though. It's going to trend towards 0. That's where this y equals 0 is coming from. And then the last one is when the degrees are more in the numerator. If the degrees are more in the numerator, you can see that's number 2 and number 4, the ones that are left, they don't have a horizontal asymptote. And the reason is I can divide x cubed by x squared and get a number. Now that's not to say there isn't a pattern there, and that's something you'll look at more in pre-calculus. So let's summarize. In a rational function, when the degree of the numerator is the same, we are going to divide the leading coefficients of the numerator, and close enough. I feel like I'm spelling that wrong. D-E-N-O-M-I-N. There we go. All right, so if the degrees are the same, we're going to divide. If the degree in the numerator is smaller, so if it's like bottom heavy, we automatically are going to have an asymptote of y equals 0 because the denominator, here we go again with the spelling, in a sense, overpowers the numerator. Now, the last situation is where the numerator has a higher degree. Then we have no horizontal asymptote. A lot of spelling in this section. And the reason for that is because you can divide the numerator and denominator. There's one thing we need to add to this, and that is if there is a constant at the end. So, for example, let's say, move this down, let's say we've got something like f of x equals 1 over x plus 2 plus 5. Well, here the degree is larger in the denominator because there's an x in the denominator and nothing in the numerator. So right away we would say, hey, y equals 0. But then we have this pesky 5. So really it's like 0 plus 5. So we would end up with y equals 5 as our horizontal asymptote. To give you another example of that, let's say we had f of x equals 6x squared, move the recorder, divided by 2x squared plus 3. And then outside we had a minus 8. Well, first we would look at the degrees. And here the degrees are the same, 2 and 2. So as we put bigger and bigger numbers in, no one cares about the plus 3. The x squareds would divide out, and we would just be left with 6 over 2, which would really be y equals 3. But then we have the little minus 8, so subtracted, and we would have y equals negative 5. So that's what we do if there happens to be a constant afterward. Now, what about those vertical asymptotes? In a rational function, to find the vertical asymptotes, we set the denominator, enomimator, equal to 0, and solve. These values would make the denominator, oh man, there's a lot of spelling, O-M-I-N-A-T, 0, and basically we wouldn't be able to evaluate the function. All right, so going back to these cute little examples I wrote up here. Over here we've got x plus 2. If we took x plus 2 and set it equal to 0, minus 2, we would get x equals negative 2. That would be our vertical asymptote. Now, for this one that I just totally made up off the top of my head, if we took 2x squared plus 3 and set it equal to 0, common sense immediately tells you there is no real solution here. Hey, guess what? That means there is no vertical asymptote. There is no number that will make this denominator equal to 0, because if you think about it, we're squaring a number, we're making it positive. Then we're going to double it, then we're going to add 3 to it. There is no way you're going to get 0. So this one would have no vertical asymptote. And sometimes you have to be careful because, like, let's say you have f of x equals, let's say 4x squared divided by x squared minus 49. Well, again, degrees are the same, so we can just divide. 4 divided by 1 gives us y equals 4. But then, and there's no constant, so we don't have to worry about anything, to find the, whoops, no, I was right, vertical. Why did I cross that out? To find the vertical asymptotes, we're going to say x squared minus 49 equals 0. You can factor. You can add 49 and take the square root. Either way, you get no 7s or negative 7s allowed. And those would be the vertical asymptotes. And you can put that on your calculator and check. Let's do that, just for fun. So, come here. Nope, don't go full screen. So we go to y equals clear, parentheses, 4x squared divided by x squared minus 49. Let's take a look at the graph. It should be sweet. Ooh, it is kind of sweet. Neat little U, and you can see these little things here. Now, don't do this because it'll mess up your settings, but I'm going to do it just for fun. I'm going to zoom out. So you can see, zoop, there it goes. There is at negative 7, there it is at positive 7, and there it is at 4. And again, you can always go look at your table if you have access to your calculator. Key phrase there, if you have access to your calculator. What happens when I don't let you use your calculator? We do it ninja style. Ladies and gentlemen, I have 12 questions here. All I want you to do is state the vertical and horizontal asymptote for number 1 to start. On your mark, get set, go. Okay, hopefully you came up with asymptotes of -4, x equals -4, and y equals -5. If we set x plus 4 equal to 0 and solve, that means we are not allowed to put -4 in the denominator. Additionally, the fraction would give us an asymptote of 0 because it's bottom heavy, higher degree in the denominator. But then we have a constant here, so 0 minus 5 gives us y equals -5. We are also asked for the domain and the range. The domain and the range here are going to be very simple for our purposes. All it's going to be is all real numbers for the domain where x cannot equal -4. And for the range, all real numbers where y cannot equal -5. So take a minute, find a buddy, pause the video, and try the other 11 problems. I will slowly reveal, well, actually pause the video, and I'll reveal all the answers in a minute. Okay, so before I scroll down, I want to remind you that you have 2 pages to do for homework tonight, 9.2a and 9.2c. These are no calculator. You should not be using your calculator for these. If you want to use it to check, that's fine, but in terms of finding the asymptotes, you need to know the rules and how they work. Here are the answers for these 12. I'm going to go forward a page in a minute so that you can see the homework answers if you want to use the video to check your homework. Okay, and here are the answers for practice A. And here are the answers for practice C.